But suffice to say that it's a type of brandy that has considerable renown and second only to cognac, I guess, in the world, and comes from a region sort of southeast of Bordeaux, and with what's the geographical department of Gers, G-E-R-S, which the capital, the principal main town is Auch, where there's a certain amount of commerce in brandy, although not very much production that far south. This this little map here, which is a little small to see, I realize, but doesn't show the location within the country of France, but it does show the outlines of the department of or the Armagnac region. And most of it is produced up here in the northwest. And they have, this is the capital city of the, and several of the other towns of fame and production are Oz, Condom, Vic Fezensac, and and these towns are in the region. Again, the tendency, eagerness to classify things results in a classification of the Armagnac district into three sort of quality areas, and they are in the order of related quality, called Bas Armagnac, and Tenerez, A-R, T-E-N-A-R, E-Z-E, and Haut Armagnac. In other words, this is considered to be the region produces a bit most quality, and where most of these important producing centers are located, and a few of them are in this district, and very little produced in the Bas, I mean the Haut Armagnac, or the lower part of the district. Well, anyway, I think we already indicated that they, of course, produce brandies using white wines, white grapes, and these are quality regions. You have a question about this?
I'm trying to work out what words you had there.
Here?
Yeah.
T-E-N-A-R-E-Z-E, Tenerez.
These are
Tenerez. I guess those are accented. Question?
These are appellation control regions?
Yes, they are. That's right. That's a good point to make. AC regions. And occasionally you do find on the labels the word Bas Armagnac. But I don't think you ever find the other two. But apparently if it's produced exclusive from that, sometimes they claim that quality, that appellation control. Well, as I said before, I think in the laboratory that the literature connected with Armagnac usually says that they produce the wines from the variety Picpoul, P-I-C-Q-U, I'm not sure there's an E in it, I guess there isn't. Picpoul, said to be the same as Full Blanche. However, there's a considerable, it's fairly well known that they have used considerable of a couple of hybrids or direct producers. One known as Baco 22, 22A, and the other in the variety Noah, NaOH, or NOAH, I guess it is. NOAH, yeah. But anyway, when I was there a good many years ago, there was a considerable unsettled situation as far as production of Armagnac brandies was concerned, namely that the farmers were finding they could make more money by selling the wines as wines rather than brandies and holding them. And so over half the production of wines that were vinified were going into wine, maybe ordinary wines, but at least they can make more complete wine than they can farther north in the Cognac region, because it's a little bit further south, a little more favorable climate on the average. However, I understand now there's sort of a resurrection of interest in the Armagnac, and some of the smaller firms that were having difficulty making out in the past have kind of merged or associated, and some other outside interests have come in. For example, Mr. McWilliams, Doug's father, was telling us that there's a very large plant now, I think, in this town of Condom, put up by a firm in Germany known as Osbach Uralt, or the Asbach company, which is at Rudesheim on the Rhine. It produces a German brandy. Now they've come in and built a big plant in Armagnac with continuous columns to make spirit to be transported to Germany. And one of the producers that I had visited before, by the name of Jeannot, is apparently the firm who has cooperated and produced this plant. Well, anyway, traditionally the brandies were produced in a type of still, which is known as the Verge System. And I gave you a little sketch of this some time back and pointed out that it's rather interesting design in that it's the wine is fed in continuously and the products produced continuously. So in effect, it's a continuous still. However, instead of having a continuous discharge of the stillage or the vinasse at the bottom, it's done intermittently, and the heat is supplied as a direct fire. So in other words, looking at this diagram, if you've got it here in front of you, the wine goes into a preheater, which is the first part of the condenser, or in other words, the first condenser is called the chauffe vin, or the preheater, and the wine goes in here, and for all practical purposes, you can sort of neglect this part up here, this defligmator, they call it. I think in practice that it's not that the seed comes in the bottom here, but there is apparently some type of arrangement whereby they can run the wine in through that, and somehow get some separation of heads in this thing, but it isn't very clear to me just exactly how they'd operate. So for practical purposes, then we can consider the wine comes in here, is preheated, comes out the top, comes out here at the top, and flows into the top of the column. And the column consists of anywhere from 7 to 10 or 12 plates, usually. I don't know, well, they can be either bubble cap or some of them perforated trays. And of course, and it's heated by the boiling vapors off this pot, and in effect, it's a stripping column. And the vapors stripped off go off the vapor pipe and are condensed. And it's as simple as that. The distillate is about 52% alcohol, about 104 proof. And of course, the interesting thing about it is that they have a firebox around this, much like they do in the cognac types. And the bottom level of this boiler is heated by the direct fire. They were still using wood when I last visited there for heat. I suppose they've converted to gas by now also. But the vapors from that bottom pipe bubble through one or two large inverted U-tubes, which in effect makes the upper level a sort of a large bubble cap, so in other words, stage of vaporization. So after a certain period of running, when the tests show that this is down to a level of alcohol, 1 or 2%, they drain it down to within a few inches of the bottom, and then open this side cock and drain the upper level down into the bottom part, and the process continues. So that's called the Verge system, and has been in use for many years. And my understanding that essentially was a required by the appellation control laws that this method be used. This is a little far to see, but here's a picture of one where here's a pot here enclosed in a firebox, and the man here is putting a stick of wood in the furnace, and here's the column, here's a vapor pipe, and here's the preheater, and here's the residual condenser or cooler. Now this doesn't even show, you see, a so-called reheater deflagrator at the top, ratio four deflagrator. But you can see clearly this is the wine flow pipe, and here's the vapor pipe.
Now the wine flows in over here by the condenser, right?
Well, the wine flows in. I don't know exactly where the line is here, but one of these pipes here would be the wine line, I guess. And then it goes through the preheater, and the preheated wine goes over here and in the top of the column, just like this diagram indicates. It was exactly like this diagram, except this particular picture does not show one of these preheaters up the top, and I'm not quite sure what the value of that is, although some other pictures I have do show that. For example, here's another. This is too small. Maybe I better pass it around. Here's one here though, where it's you see it's mounted on wheels, wagon wheels, and of course this indicates that they used to they have a lot of these that were portable and would carry them around and do the distilling and move on to the next site and so on. But now this one is located inside a building, and I saw several like that that had been originally built to be portable, but they'd jacked them up on blocked them in place in a building and used them stationary fashion. But here in this one, if you look carefully, you can see there's a little tank there between the column and the condenser or the preheater, which corresponds to this deflagrator pot. And there's another picture here of one out in the kind of a silhouette of a couple of oxen drawing one with the wheels, and there's a distillery being transported around. So if you're interested in glancing through that, pass it around. So anyway, the distillation has traditionally been in a very rather simple fashion, a classic fashion, and the cognac is. The Armagnac, rather, is aged in, said to be aged in casks of the region. And the general region, or the old name of the region, is Gascony. So we speak of Gascony oak. And it's said to be sort of a black oak. Now that doesn't mean it corresponds to what we call black oak, but it does. It is a type of oak that apparently has a little bit tendency to give it a little darker color, or maybe a sort of blacker type shade to the brandies. Anyway, traditionally the local oak has been used for aging. In what I remember was about 400-gallon casks, and somewhat contrary to the cognac practice, most of the brandies, at least in the past, have been sold pretty much as straight brandies, and many times you can get age. The age is claimed. For example, we'll have one in the lab this morning that's has an age claim on it. I guess the one we tasted last week also did have an age date on it. Well, I just also learned recently, and it was pointed out in this what to do with that this little magazine I showed you yesterday, that there's been some dissatisfaction with this method of distilling on the part of some of the producers in Armagnac, and so evidently they have permission now, are permitted to use cognac type pot stills. And again, I guess it was Mr. McWilliams that mentioned this to me, but looking in this magazine here that I had passed around yesterday, Revue Le Paysan, let's see, that's not the one, I guess. There's a picture of one here which specifically says it's created for Armagnac, one of those large installations. Now, the one by Maresti, the one here with these pots on this side and the condensers on the other, and it says here, installer for Armagnac. So evidently they're producing, they're now beginning to use the pot still method Charentes in Armagnac. So that's about all I can say about it. Well, that's all I say about Armagnac, unless there's some questions. Yes?
I heard a rumor that they dry pumice and use that to fire up the brandy still. Do they do that in the region?
I've never seen it done. In Algeria, I've seen it done, where they use the pumice to heat the boilers and to operate the plant. It's a messy job, but they have a lot of manpower that deliberately shovel a huge pile of pumice into the boilers. Sometimes they supplement with oil, or they did when I was there. And maybe someplace in France they do, but I've never seen it used in France. Another question?
Yeah, but still, I understand the vapors come off, and it looks like they go back into the preheater.
Well, they go into the coil, the serpentine of the preheater, where they're condensed. The preheater, of course, is heated by the vapors, by the condensing vapors. So it's partly a matter of recuperation of heat. And it's been said that if the alcohol content of the wine does not exceed some figure around about 7.5 or 8 degrees, that you can operate without water. In other words, use the wine entirely for condensing. But if it's higher degree than some figure that I recall, around 8 degrees, by then there's enough more excess vapor, more alcohol, so then they have to use some water in order to get it down to proper, to get it completely condensed and cooled.
They don't give this a second distillation, do they? They just do it once.
Just do it once. And it really would correspond to what we might call, or in the bourbon industry they'd call high wines. It's just to distillate off of the stripping column. But and of course the concentration of the alcohol on the top tray, in order to give 52%, you could look it up in your chart here, it may be slightly more than the level of wine, but you can operate a column so that you can maintain that alcohol strength. It may be a little higher alcohol than the feed itself, but it wouldn't be much, I think. I'd have to look it up again, what percentage in the liquid at equilibrium to give 52 degrees in the vapor. Maybe it's something like 15%. Well, all right, then I was going to make a few remarks about whiskey production. Well, that's what I'm coming to. That's used in Scotland. That's the coffee still, patent still. But I think a few weeks ago when we handed out this little handout here about steps in the production of whiskey, primarily in the USA, we went through this down to more or less to the distillation step, and maybe we talked a little bit about that. You remember that the steps here were discussed as milling of the grain, the mashing of the grain, including the cooking and producing the mash, and then the yeasting and fermentation, and then finally the distillation. And we pointed out that the fermented mash is called beer. And so the still in which it primarily goes is called a beer still. In reality, it's mostly a stripping column. And they usually have about 22 perforated trays, and 1 to 5 actual bubble cap trays at the top. So in a way, it has a very short rectifying column at the top of the beer still. And and 1 or more of the condensers usually acts as a preheater. And if you have this chart in front of you, these charts, you turn over to the first page of the split drawing here, and I get to the last page, and you see here the beer still. It's just it's a regular column, and and you see in this case it has 3 separate beer heaters illustrated in this drawing at the top, so that the beer from the beer well, or in other words, the supply tank, is pumped through those 3 heaters in sequence, and then is preheated and runs into the lower part of the top section of the column, or in other words, the top stripping plate of the beer still. And then it has a water-cooled beer column deflagrator, they call it here, plus finally a gas cooler or a vent condenser. So in reality, as this is illustrated here, they show 5 separate condensers. And of course, all of them are connected to the product line as well as reflux line. So they can control the product composition somewhat by controlling the amount of reflux to the top of the column. So in producing so-called bourbon-type distillates, or what they call high wines, the distillate is drawn down here and comes down directly from that deflagrator, and then you see it can split to the right or to the left, and for the bourbon-type distillates, it goes to the left in what's called a continuous whiskey doubler, which is nothing more than a big pot still heated with a steam coil. And so the distillate from the beer still, which might be something 110 or 120 proof, is generally once doubled, as they call it, in the doubler or in the pot still, so as to get a distillate that's approximately 160 proof, or not more than 160 proof. And of course, this shows a line out of the bottom of this doubler going back into the top of the beer still, beer column. In other words, the proof that they'll get out of the doubler, of course, depends a little bit on the how completely they vaporize it. In other words, the fraction vaporized, you might say. In other words, this is sort of an example of a flash distillation. That's what it amounts to. So the concentration will be a function of will be higher as the fraction vaporized is less.
Not a batch thing.
It's a continuous. Well, it can be operated semi-batch wise, but the way it's drawn here, it's a continuous. So in reality, it's a flash distillation. See? Exactly, it's the flash distillation process. If everything is kept in balance. So at the bottom liquid, that part that's not vaporized is, of course, lower in alcohol. Let's return back to the top of the beer still. I think this practice is pretty universal, at least in the Kentucky area. And I think you could find several variations of this. I think you could find in some places, perhaps in Peoria, Illinois, and even in Tennessee, where they don't use a doubler, where they may actually feed the high wines into a short fractionating column, much like we do in California brandy production, and draw off the high wines or brandy, whiskey distillate as a side stream product. But I think this practice is more common, as indicated on this chart here. Now, to continue a few minutes with the chart in order to indicate some of the features of this, the rest of the distillation setup here, which is primarily for producing neutral spirit. See, looking at this sketch now, we have a heads column going from right to left, an extraction column, a fusel oil column, and finally the last one shown here is a spirits column. So, in other words, if they and there are considerable variations in the way these columns are organized between different companies. But anyway, following the plan here, you see the high wines off the beer still would go into the middle of what they call a heads column, and they would take off from the condenser at the top a heads fraction, and then the unfinished spirits out the bottom of that, which would contain most of the alcohol, essentially stripped of aldehydes, would then go into the middle of this extractive column. Now, the extraction column is so called because you change the relative volatility, the volatility constants of the components you're interested in by changing the solvent. In other words, the alcohol water medium. In other words, you actually dilute it down to low alcohol in order to take advantage of the gradiently enhanced volatility of some high boiling materials like fusel oil components and fatty acids and so forth. And so they have down here, they actually show here that the hot water is taken off is supplied as the residue from the spirits column over at the right. So it's pumped over here and into the primarily into the top level of this extraction column. And so, depending upon how much water they use, they'd have a rather dilute. You could have a dilute, more or less, alcohol level throughout that column. In which case, the higher alcohols, as well as the other high boilers, go over the top in the distillate. And of course, most of the alcohol comes out the bottom again as unfinished spirits, and then is sent over to the spirits column. Meanwhile, the top distillate from the extraction column comes down and as shown there, at least an alternate pathway is shown as going into the fusel oil column, and where the fusel oil is concentrated to the point where it can be drawn off and separated in a fusel oil decanter, which is indicated there by the names. And finally, the spirits are taken off as a side stream near the top of the spirits column, which may have 50 or 60 trays in it, and then you can produce a spirit up in the level of 193 proof. And so the product would be called green neutral spirits. Now, of course, the primary purpose, use of that, well, there's been several uses of green neutral spirits. One use, of course, is blending with bourbon whiskeys to make the so-called American whiskey blends. And you'll notice that on labels that are called blended whiskey that they will have, they'll specify that has such and such a percentage of straight whiskey so many years old, and maybe another percentage of a different age, and then 60% green neutral spirits. In the use of neutral spirits, The only requirement is that the source material must be associated with the name. For if it's made from grain, you call it grain. If it's made from fruit, you call it fruit neutral spirits. Now that's one use of this.
What proof is that when it hits the outline? After it comes out of the spirits cooler, it's what, about 180, 100?
No, it'd be 190 or two, probably as a minimum. 192 or 3 would be what I would expect, because you're concentrating it almost to as high as you can get it. Well, there's two other uses then for grain neutral spirits in the American grain and spirits industry. And one is production of gin and one's production of vodka. And it shows on the right hand here a little gin still. Well, there are some various designs here, but this is a type used by this company where they use a pot still, which I think is the same as a Scottish pot still. And so in other words, they put in to this pot alcohol at a certain strength. It's usually diluted down to something of the order of 160 or 170 proof, as I recall, and then mixed right in with it in the same liquid is a certain formulation of botanicals or flavors, of which juniper berry is the most best known, but it is only one of several herbs that are used, and various companies have different formulations. As a matter of fact, the same company may have 3 or 4 formulations and use it for 2 or 3 different labels. And I might mention, I was trying to find here a certain formula that
Are these held as trade secrets, you said?
they're usually sort of trade secrets. One of the producers gave me some figures one time on the amounts used, and I'm trying to find it here. Well, anyway, I can mention some of the products that are used in the approximate proportions, and I can't quite find now what the concentration the rate at which they use that. But anyway, some of the materials that are used besides juniper berries include sweet orange peel, bitter orange peel, sometimes lemon peel, cinnamon bark, cassia bark, which is a sort of clove, the flavor of clove, cardamom seed, nutmeg, orris root, coriander seed, angelica root, and so those are some of the products that are used. I think most of them would have something like would maybe use about 5 to 8, but not necessarily all of these. Some gin formulas are maybe a little heavier in orange peel. One here, Gilbey's, is said to be heavy in cardamom, and I can't quite figure out what the levels used here that are per 1,000 gallons. I've got it here somewhere, but well, here's one statement here that from a visit of one of the distillation representatives, that per 1,000 gallons of gin they used in one formulation about 26 pounds of juniper and as much as 20 pounds of coriander seed, and but only about 3 or 4 pounds of angelica root. Now that's apparently a simple formula, and as I say before, they usually have 5 or 6 different herbs. Well, here's a formulation here, which I don't know how to translate in terms of 1,000 gallons, but it had 25 grams of juniper berries, 3 grams orange peel, 3 grams of coriander seed, 3 grams of angelica root, 2 grams of cardamom seed, and 2 grams of cassia bark. So that was approximation of some formulas that are used. Well, in other words, they put all this botanicals in the pot and distill it off, and in the process of distilling, the flavors are absorbed or entrained into the distillate. So then they adjust it to the proof for bottling. That's about all there is to it. Yeah.
It's kind of interesting, but those are the same ingredients you use to spice a roast beef in England. The last one, practically identical.
Well, that's interesting. Maybe
They use the same spices as they use in the beef.
well, we don't. Well, that's interesting because, of course, gin was a sort of a product of somewhat of an infamous product, you might say, at one period in England, and although I think the name originally started in Holland, but anyway, in I guess the 18th century, or what part was it there, when alcoholic spirits were quite cheap, and England was renowned for the drunkenness associated with gin, the gin mills that they call them, and there was quite a bit of social turbulence over taxing and whether or not, and the general state of drinking gin. Of course, England is renowned now for some of its quality gin, so maybe there is some connection.
Yeah, quality gin drinkers.
Well, and then a few words about vodka. In other words, vodka is nothing more than about the purest spirit you can get, processed in such a way that it has as little residual flavor as non-ethyl alcohol as possible. And so the company that was most successful in this country of producing and popularizing vodka was Hublin, I guess, and where they produced the label Smirnoff, and they had a patent on the process by which they treated it with the spirits with charcoal. They had a certain procedure where they had a sort of, again, like a diffusion battery arrangement of 8 or 9 vessels in which they charged charcoal. I'm not quite sure what the type of charcoal was now. I didn't look that up. But anyway, they would the spirits to be treated with the charcoal would go through 7 or 8 of these tanks in sequence. Then after a certain period of running, then they would stop and empty the charcoal out of the one which had been, let's say, had 7 or 8 previous passes through, and charge a new tank, one of the tanks, with the fresh charcoal, and this would be the one which the spirit went through last. I mean, and then the incoming spirit, the crude spirit, if you want to call it crude, although it can't be very crude to make it into vodka, would go into the tank which had the most number of previous passes through. So it's a kind of a countercurrent type operation, similar to the old diffusion battery, as I pointed out, and similar to the process in principle that I try to describe in the laboratory for producing the pumice brandy, or the eau de vie de mar in France, where you have maybe you only have 3 or 4 in a series, but So that was the process. Now, and so this drawing here also indicates a vodka charcoal treatment tank. Now, evidently, either they don't show, or they only depend on one single batch treatment for producing vodka, as the chart indicates. Well, anyway, for quite a while, the federal specifications or standards of identity for vodka provide that it be treated with charcoal. However, more recently they've dropped that requirement because some of the distillers claim that they can make vodka grade spirits purely by distillation using extraction techniques and sophisticated distillation procedures, and they don't use charcoal anymore. That's my understanding. I don't know exactly how it differs from this kind of a distillation setup, except probably they got maybe a couple more columns in there. Yeah.
Does it matter much what distilling material you use for vodka then, like grains or just anything that comes around?
Well, they use it's made of grain, but the grain formulation can be different than for bourbon. It and usually is, to a certain extent, somewhat cheaper grains. I think I gave a typical batch formula for on the first part here. For bourbon, typical mash bill: 68% corn, 20 rye, and 12 barley malt. Now, by law, it has to be at least 51% corn. But I guess I didn't put in there formulations for neutral spirits, but they depend a little bit on the price of the price, but they can use any kind of grain that's suitable, and it depends on the price. Usually it would be corn and rye, and sometimes they use milo grain.
What about spuds?
What?
What about potatoes?
Well, they couldn't call it grain spirits then, and that's what they want to still be able to call it. They don't use potatoes. Of course, you can use potatoes, but they don't use it in this country that I know of. I don't think they do in Russia as much. The fame of Russian and Polish vodka was based on the use of potato spirit, and I'm not so sure that they use potatoes now. I think they use grain. I'm not sure about that. Yeah. Well, now I'll take a few minutes to try to talk about Scotch whiskey, and I don't have a specific handout here for this, but suffice to say that in most parts of the world, when you say whiskey, why you automatically understand Scotch whiskey, or whiskey from Scotland. And and it has a long history, which you can find described in books. And it's only been a little over 150 years ago that most all of it was illicit distilling, and they had quite a time of getting the industry to accept the Licensing Act, which provided for illegal spirits and, of course, provided for taxes. One of the first ones to do this was a man by the name of Smith, who made a lot of fame, and he was located in the little town of Glenlivet, up in the Scottish Highlands, which is up in the northeast part of Scotland, and so his product was called Glenlivet. And so the fame of his product spread to the point that the other people finally decided they better come in under the rules and follow his example. And his fame had spread to the point where all the other distilleries, and there were quite a lot of them by this time, I guess this was about 1830 or 1850, I'm not quite sure the dates now, that they all started putting a word Glenlivet on their labels. So so this Mr. Smith had a suit and prolonged the hearings, and so he finally won at least the right to the exclusive use of Glenlivet. As a compromise, they let a lot of his neighbors and competitors use the word Glenlivet as a hyphenated part of the name. For example, we might have the word Glenfiddich dash Glenlivet. And so forth. Can't spell that one. Cregelici. C-H-I-E. Cregelici Glenlivet. And so forth. It seems to me like the tendency nowadays, however, is to and this applies only to the all malt scotches produced in the Highlands. There seemed to be a little bit of tendency to drop off the word Glenlivet and just depend on their names, on their original names. But anyway, the origin of Scotch whiskey was in the Highlands, primarily between England, Inverness, and Aberdeen on the northeast coast, and particularly centered around the town of Elgin or Elgin, and along a river called the River Spey. Some of the most famous names. However, there are some other places, like some of the islands, where there's all malt Scotch whiskey made. But now then, to get down now to a few specifics about it. We have two types of Scotch whiskies, and one is, and the original one would be an all malt pot still whiskey, or usually called all malt. And second, blended. Well, for a long time, all the products were made were all malt and made in small distilleries, as I say, in the Highlands, usually in the Highlands, and they were usually located in the Highlands and in a little glen or along a brook or a stream, because they considered that the water was very important and the temperature of the water. So they all were located along a little flowing stream, or burn, as they were called, in order to provide the water, to operate the, well, not only the condensers, the still, but to provide the water for making the mash, or making the mash, not the word I'm trying to think of, think of it in a minute. But anyway, these distilleries, and you can find some of them described in pictures of it in some books, like this one here by Scotch Whiskey by Robb. Here's one, Scotch by Bruce Lockhart, Robert Bruce Lockhart. Anyway, the process in these Highland distilleries, it consisted of making the malt, as well as making the wort, that's the word I was trying to think of, and fermenting it and distilling it. And so the process was to make the malt. And first of all, then, they take the grain, which is barley, always barley, preferably that grown in Scotland, but it's not required that it all be grown in Scotland, and most of it's not now because of the volume. But anyway, the barley is steeped in water for a few days to soak it up, and then the barley is, in the old process anyway, was spread on a floor maybe 8 inches deep. And then in the oldest ways, it was turned daily by hand with a couple of men with the shovels. And they'd go down and they'd shovel it so as to keep it uniform and keep the moisture so it'd be not drying out the top and too wet at the bottom. And there's been also some, and then there also was some mechanical devices like a plow that you'd mount it on a track that you'd run down along there, and it had an auger and sort of turn it. And so there's been a certain development of mechanization. But anyway, in the process of something around 10 days, as I recall it, the barley begins to sprout, or that it begins to germinate. And it does form little rootlets, although the development of the enzyme, the maltase, is such that it reaches its desirable level, or maybe the maximum, before the sprout emerges from the grain, but the little rootlets have formed. So anyway, by proper examination, either visual or maybe some tests, they decide that it's time to dry it. So then this partially germinated or barley is then put into a drying kiln, which is consists of a cupola-like building. Get a picture of one here in a second. It's I wouldn't be able to have difficulty finding one when I'm looking for it. Well, anyway, as you can see here, it's a little too far away, but you can see they have these, as part of the scene of a Highland malt distillery, you'll find this drying kiln, which always has a little cupola with a top over it, and this is where the gases go out when they're drying the malt. And it looks a little bit like the old hop drying towers we used to have here in California. Kilns, you might call them. Anyway, the barley is spread across on a perforated floor or screen-type support above direct fire, and the fire does the drying. And to a certain extent, some of the flavor is imparted at this time because traditionally the fire is a mixture of coke and peat. Peat, the low-quality carbon fuel that's going to be dug up in the bogs around in the highlands. And this is dug up over a certain period of time and put in stacks and dried, and it forms a coarse fuel. Sometimes it's used for heating in the homes, but it's also partly thrown onto the coke fire, and so some of the smoke materials, or the degradation of the organic material in the peat, gives a certain smokiness to the Scotch barley flavor, the malt flavor. So anyway, that's the malt. Malted grain. Now, but it's only apparently a sort of low-level malt. In other words, the activity is not very high, and most of the barley is still, most of the starch is still in the grain, in the starch form. So, in producing the medium to be fermented, the wort as it's called, they simply, of course, they have to grind it into powder or grain, and then it's steeped in a mash tun with hot water, and then sometimes there's a 2 or 3 stage rewashing process. But in essence, then the grain is stirred up and suspended in water at roughly 150 degrees, 140, something, 8 maybe it is, and held for a certain length of time, during which period the malt enzymes convert the remainder or bulk of the remainder of starch into fermentable sugars. And so this is drawn off as a liquid. It usually has a rather nice brownish appearance, and then yeast is added and it's fermented. And this material then becomes the beer or the charge for the distilling. So I just wanted to make at this point the contrast here between practice in the United States and in Scotland in the sense that for the all malt whiskies they did not use any adjunct grains, no rice or corn or unmalted grains whatsoever. And they also ferment a clear liquid or a uniform liquid, whereas in this country, for bourbon manufacturing and elsewhere, we use a high-level malt to convert the starches of adjunct grains. And furthermore, we do the fermenting all in the presence of all the solids, and separate the solids after distillation. Whereas in Scotland, for the Highland malts, they separate them before fermentation, and they have something use such as feed grains for the grain residues. Well, time is up and a little past. Maybe tomorrow or maybe in the lab I can mention that the blended whiskies then is a development that started when England became interested in Scotch, along about 1850, I guess, or some in that period. And it was made possible by the development of the coffee still, which I gave you a little sketch here, and I won't take time to discuss it, but it was a continuous still with a stripping column and a rectifying column with a little bit of unique design, usually with square cross-section. One of these books has a picture of one in here. And so this was called grain whiskey, the product made in this, because here they did use adjunct grains, and like we do in this country, more or less, except they used a clear wort to ferment. And so then the blended whiskey then is a proportion of this patent still or continuous still whiskey with malt, all malt whiskeys, which may have 3 or 4 or 5 or even more different products blended together into making a blend from the malt and then the grain spirit. But anyway, the grain spirit is not, the grain whiskey is not quite as neutral as we make in this country. In other words, it's made at what's equivalent to about 188 proof, as I remember. So it has some flavor, and it's also aged in wood for a minimum of 3 years before it's used in blending, in blended scotches.